Good morning, everyone. Today we're going to be starting on equations of lines. So a bit of a brain warm-up today. Feel free to pause the video and try this out on your own. Some of the sort of skills that you should have already. Being able to identify coefficient, constant, and degree of a polynomial. So yeah, just maybe pause it for a sec, try to fill this out, and I'll go through it right now. Okay, so the degree of this first polynomial, 5, the degree is 0. So the reason for that is the variable, if you want to call it that, is to the 0. So that's just 1. So there's no variable there, so the degree is 0. The leading coefficient, I guess there's nothing attached to a variable, so not applicable, or 0 would be fine. Constant is 5, and if you were to graph that, it would be a line, it would be a horizontal line. Okay, next one, the degree of this one is degree 1, so it's 3x to the 1, I guess, if you like. The leading coefficient is 3, and the constant term is positive 1. This would also be a line. Next one, the degree, you pick the highest exponent for the term, so the degree here is 2, leading coefficient is 2 because of that one. The constant here is positive 2, and this is not a line. This turns out to be a parabola, so it looks something like that. Okay, and then 4x cubed, so the degree on this, the highest exponent is 3, leading coefficient is 4, and the constant term is positive 2. This is not a line, it is a cubic function, and it looks kind of something like that. Alright, so you can see a linear function is a polynomial function that is either degree 0 or 1. And what kind of line did a degree 0 polynomial make? It is a horizontal line. Okay, and we can check that in our graphing calculator. You can see if it turns on, there we go. So you can graph the line y equals 5. See what that looks like? So it's just a horizontal line that passes through y equals 5. Okay, moving on. So horizontal lines. Horizontal lines, again, are defined by a degree 0 polynomial equation. They're also called constant polynomials. So y equals k, where k is some real number. Okay, so let's sketch the graph of y equals 3 and y equals negative 3 using our calculator. So we can do, where's that thing? Okay, here we go. Again, y equals, clear that. So y equals 3 is there, and I can put y equals negative 3 there. If you have just a regular TI-84 plus, you obviously won't have these colors, but it's basically the same kind of experience. So there's the line y equals 3, and there's the line y equals negative 3, so in the red. If you wanted to sort of make these lines look different in just a black and white display, I guess, I don't know if this will work. So you could make, oh, interesting, I haven't tried that before, never mind. You can make those lines thicker or dotted by scrolling to this area and then hitting enter, and then just keep hitting enter, and you can make the line thicker or dotted or anything. Okay, so anyways, that's enough of that. So now we want to, so we're going to sketch this. So find a line here. There's the line y equals 3 and the line y equals negative 3. I guess I should have arrows on both ends of that. So this is y equals 3 and this is y equals negative 3. Okay, look in the table of values generated by your calculator for each one. So let's check that out. So if I want to see the table of values, I go second and then graph. And that should, okay, there we go. So we see a range of x values. And then for the line y equals 3, it is 3 for all values of x, no matter where I go. And for the line y equals -3, it's always -3 as well. So it's unchanging. All right, how do the y values and the tables of values relate to the equations? Well, y1 equals 3 is 3 for all values of x. All values of x. And y2 equals -3 is -3 for all values of x. Okay, without a calculator, draw the graphs of y equals 5 and y equals -1. So same kind of concept. So y equals 5 will go through there, and y equals -1 will go there. Should go in both directions, so just arrows in both directions. That's y equals 5, and this is y equals -1. Done. Okay, moving on to oblique lines. Oblique lines are lines that are neither horizontal nor vertical. In general, all oblique lines are degree 1 and can be expressed in the form y equals ax plus b, where a and b are real numbers and a can't be 0. So if a was 0, we just have a horizontal line because, so suppose I had a equals 0 and b equals 5, for example, y equals 5, that would just match up to this line that we just did, which is horizontal. So a cannot be 0 because otherwise it'll just be a horizontal line. So in this equation here, the leading coefficient is a and the constant term is b. So recall, for a linear function, a constant change in the independent variable will produce a constant change in the dependent variable. So in words, delta y over delta x, we've seen this before. So delta y is just, it's like that formula we looked at last time, or last couple lessons, x2 minus x1. So if we do one over the other, right, it's just, it's the equation for the slope or the rate of change. So rate of change or the slope. So I guess if you're going to write that down, that might be a little bit weird to see something with stacked equation equals signs, so I'll just maybe make that a little bit more appropriate. So delta y over delta x is that thing. So we've seen that before. It's the rate of change or the slope. Okay, moving on. So let's look at some linear functions in the form y equals ax plus b. So without a calculator, fill in the table of values and plot the points on the grid. So there's an easy way we can do this with the calculator, right? It's obviously fairly artificial to be forced not to use a calculator in this course. So let's just see how easy this is with a calculator rather. So -3x plus 5. So remember, if there's a leading negative sign, do not use this subtraction symbol because the calculator needs it to be in that format. So if you did put in 5 subtract 3x, it would be okay with that input. But if you want to put the -3x in the leading term, you'd have to do -3x and then plus 5. Okay, and then you can graph it, obviously. So it looks like that. And we can check out a table of values. So 0, 5, 1, 2, 2, -1, and 3 is at -4. So I can just fill all these in based on the table. So that's 5, 1 is 2, 2 is -1, and 3 is -4. Obviously not too tricky to do this by hand as well. So when when x is 0, y equals -3 times 0 plus 5. This first bit gives you 0, and then 0 plus 5 is 5, right? For x equals 1, -3 times 1 plus 5. So this first term gives you -3, and then 5 subtract 3 is 2, and so on, right? So fairly straightforward. And then if we want to graph that, so we can just put these points in. So 0, 5 will go there, 1, 2 will go there, 2, -1, right 2, down 1, and 3, -4, right 3, down 4. And then we can just connect those points with a line and extend it in either direction. So I'll just maybe go like that. And there we go. So, and then that will extend in both directions. So fill in the table values, check, plot the points on the grid, check, and I just drew a line through it as well. Okay, next one, y equals 1/4. When x is -4, so plus 2, -1/4 times -4, you can write it out like this if you like. I guess I'll do that in order. Put the negative in front. So 1/4 times -4 over 1. So you could always write the number over 1, it doesn't change it. So 1 times -4 up top is -4. 4 times 1 on the bottom is 4. -4 divided by 4 is -1. So that's that. If I put a 0 in here, this whole thing goes to 0 there. 0 plus 2 is just 2. And then finally, 1/4 times 4 would give you 1. So similar sort of logic to this, except I don't have the negative. So it would be +1. 1 plus 2 is 3. So I can plot these points. Left 4, down 1. Is that right? Left 4, down 1. Oh, what have I done there? My mistake. Fix this. Oh, too much. So obviously, -1 plus 2 is 1. So sorry if you were screaming at your computer a moment ago. Just fix that. So -4, 1 goes there. 0, 2 goes there. And 4, 3 goes there. So let's go ahead and connect those points. That's about right. And then just make sure that they're going through as precisely as I can. Goes in both directions. Okay, let's just clear that out of the way. Y equals x plus 3, so if I put -4 in there, -4 plus 3 is -1. If I put -2 in there, -2 plus 3 is +1. If I put a 0 in there, 0 plus 3 is 3. And 2 plus 3, 5. So plot the points, -4, -1 goes there. -2, 1 goes there. 0, 3 goes there. And 2, 5 goes there. So go ahead and connect those points. So that's about right. There we go. Okay, and obviously if you wanted to save yourself a little bit of time or mental effort, you have your graphing calculator to do that for you. But obviously something that's definitely within the realm of possibility for you to do without your calculator. So try not to lean on it too heavily if you don't need to. Alright, so let's use the graphs created for the linear functions to complete the table. So this is our negative 3x plus 5. The leading coefficient is negative 3. The constant term is 5, positive 5. The slope is, so you can look at the graph, going from this point to this point we go 1, 2, 3 down and 1 right. So the slope is negative 3 over 1. So negative 3 over 1, or just negative 3. And the y-intercept happens where it crosses the y-axis, so that's 5. Okay, next one. The leading coefficient is 1/4. The constant term is positive 2. And the slope we can get off the graph if you want. So the rise to get from here to there is 1. And the run is 4. So up 1, 4 right. That means 1 over 4 is our slope. And the y-intercept is at 2. Moving on, x plus 3, leading coefficient is 1. The constant term is positive 3. The slope, so we can get that off the graph, going from this point to that point, is up 2 and right 2. So 2 over 2 is the slope, or 1 over 1, or just 1. So the slope is 1. And the y-intercept here is 3. That's where it crosses through the y-axis. Okay, so as you can see, for the oblique lines in the form y equals ax plus b, the leading coefficient a is equal to the slope, and the constant term b is equal to the y-intercept. So what letter did we use to represent slope in previous lessons? Do you remember? So it's M. You might have seen it below here as well. But, there you go. So since A is the slope, we can replace this letter with an M instead, because M is already been established. We use M for slope. So this is typical. That's kind of the preferred format that we use for slopes or equations of lines. So this is called the slope y-intercept form, and it's pretty useful in some situations. If you know the slope and the y-intercept just by looking at the graph, you can get the equation pretty quickly. So M is the slope and B is the y-intercept. Okay, moving on. Use the slope y-intercept form to write the equation of a line with a slope of 1/2 and a y-intercept of negative 3. So obviously with these exercises, feel free to pause the video and try these out on your own. I feel like you could probably do these first 3 right away pretty quickly. Just knowing y equals mx plus b, where m is the slope and b is the y-intercept. So we're just applying this formula or this equation to different situations. So this first one, the slope is 1/2, so I put that in for m, 1/2, I leave an x, right, that comes along, and plus negative 3, so I guess rather than doing plus negative 3, I have to write that whole thing again. Y equals 1/2 x plus negative 3, or just subtract 3, same thing. Adding a negative is the same as subtracting that number. Okay, next one, use slope y-intercept form to write the equation of a line with slope of 2 and a y-intercept of 0. So the slope m is 2, so I go 2x plus 0, because that's the y-intercept, or more simply, I can just write y equals 2x. So that's probably the better way to write that. Number 3, slope 0, y-intercept is 7, so we can go 0x plus 7, or better yet, just y equals 7. Alright, so next one, complete the following table, use slope and y-intercept to sketch each line. So the first one, the slope is given by the coefficient there, 2, and the y-intercept is negative 7 because that's b. So the graph A will cross through that point, and it has a slope of 2, or if you prefer 2 over 1. So to get to the next point to the right from here, I need to go up 2 and right 1, so there will be the next point, and then up 2, right 1 again, up 2, right 1, and so on. So let's go ahead and draw that line. Hopefully you have a ruler or some sort of straight edge on you, so you can connect those points. So that's A. Next one, for graph B, the slope is -3/4 and the intercept is +1. So it crosses through that point. And -3/4, to get to the next point to the right here, I go down 3, 1, 2, 3, and I go right 4, 1, 2, 3, 4. So that'll be the next point, and then I go down 3 again, and right 1, 2, 3, 4. So that'll be kind of around there. I can just make a few more points by going left 4 and up 3 in the other direction. And then I go left 4, up 3, so it'll be kind of around there. So these 3 points are pretty reliable. If we're going off the grid, I wouldn't use those as much, just because it's sort of uncertain about their position. Okay, so that would be, maybe get rid of that ish. So B, and we'll do one more. So -x subtract 4, the slope is -1, or if you prefer, -1 over 1. The y-intercept is -4, and we can graph that. So y-intercept will cross through there. The slope is -1 over 1. So we go down 1, right 1, down 1, right 1. So maybe down 1, right 1 links up with that, down 1, right 1, down 1, right 1. And for the other direction, I'll go left 1, up 1, left 1, up 1, and so on. So let's connect those with a line. Try to get that lined up. Okay, and that would be line C. Okay, so I'll just get you to do these sort of on your own. I've got a couple more here that I'll get you to send in as well. So I'll just get you for today to take pictures of, or just to take a picture of this whole page. And I want to see D and E graphed, and I want to see this filled in. Okay, so yeah, do those just on your own. And we'll try a few from 5 here as well. So use the graphs at the right to complete the table. So for line A, we see this line here. It's a horizontal line, meaning its slope is 0. It passes through 6, so 0, 6, so the y-intercept is 6. The equation of the line would be y equals 0x plus 6, or better yet, y equals 6. For line B, here it is. So it passes through the y-axis at 5, so I'll just maybe go ahead and put that in. The slope here, you're going to want to locate, so just kind of look along the line, and it looks like, I don't know, looks like the next time it crosses through the grid is here, and then that's kind of off grid. It's like in the middle of these two lines, and then it goes again through the grid, probably through there, and again through there, and so on. So maybe just work over here because it's a little less crowded. To get from this point to this point, we go up 1 and right 2. So because we go up 1 and right 2, that means the slope is positive 1 over 2. Right? The rise is 1, the run is 2. Even if you had identified a point that was further away, so not exactly the same points that I just did. Suppose you pick that one instead. So to get from here to here, you need to rise 2 and run 4. So the slope would be 2 over 4, which reduces to 1/2, which is consistent with what we got over here. So the equation of this line will be 1/2 x plus 5. Oh, fix that. I have to write it again. Okay, so -5 is, okay. Slight fix, just make sure that negative's there. So y equals 1/2 x subtract 5. Okay, and one more, c passes through -1, so I'll make sure to include the sign this time, -1. And let's see what the slope should be. So doesn't seem to cross through, like we're looking for it to cross through, right, these grid points. So if we can identify along this line where it intersects with those crosshairs, that's what we're after. So it looks like probably there, and then going along, looks like it crosses through there as well. So we can use any pair of points along here that goes through the crosshairs. To get from here to the next point, we need to go down 1, 2, 3, 4, and we need to go right 1, 2, 3. So the rise is -4, the run is 3. So down 1, 2, 3, 4, and run 1, 2, 3. So -4 over 3 is the slope. So therefore, the equation will be -4/3 x subtract 1. And if you're ever unsure about a result that you got, let's see if we can confirm, turn on. So let's just check this out. So -4/3 x subtract 1. So let's do -4/3 times x subtract 1. Let's see if that links up with the line here. So it should go through 0, -1. So I can check that by going calc value when x is 0. Okay, so 0, -1 works. Let's maybe see if it goes through 3, -5 as well. So second calc value when x is 3, 3, -5. Okay, so we're good. Should be good to go. Okay, I'll get you to do D and E here. And we'll just do a quick summary. So a linear equation is a polynomial of degree 0 or 1. An example of an equation for a linear function, we could do like y equals 7 or y equals -1/2 x plus 10. I'm just pulling examples out of air. So that sort of thing. So we need the form y equals ax plus b, where a and b are real numbers. So even if a is 0, we still have a line. It'll be a horizontal line. And if b is 0, so maybe if both a and b were 0, we would just have a line through the x-axis. And in the example where a is 0 and b is something else, whatever b is, that's where the line will go. So if it was like b equals 2, it would be a horizontal line of 2. Okay, so yes, please take a picture of just D and E for both 4 and 5. So I'll just need one picture, and please also try these questions here. And if you have any questions about any of the questions here, please feel free to reach out. So that's it from me for today. I'll see you next time.